definition of an angle of elevation is like if you were standing on the ground, the angle that you would be moving your head to look up at something. So like whenever they're like, the angle of elevation is for a building is like 22 degrees because like if you were looking up at that building, that would be the angle of elevation. And so if you have the horizontal part on the ground, the angle of elevation is that coming from the ground. So I like to draw a little guy down here and think about it's the angle coming from the ground.
That could be part of Mason's solvent. So that could just be simple.
And pretty much everything we've done up to this section has been angles of elevation. But there's also angles of depression. And angles of depression are if you're standing on something and you're looking down. So like if you are standing on top of this school, the angle looking down at a car below, that would be the angle of depression. So it's all about where it comes from. But it's not just like some people like to think about, if this is the angle of elevation, then that must be the angle of depression. But no, it has to come from the horizontal. And so now think about if I was standing up here, like here's me standing like this. Well, pretend there's a building over there. I have magical powers. I can just stand next to the building.
So you're Superwoman.
It's like the angle looking down like this. So it's like here. For the horizontal. So I like to think about it as like flipping the triangle over. Yeah?
So you stand, okay. Angle, right? You're looking down. Please just draw a building. Wait, are you looking off?
I need to draw my, this is really like my head, because it's
Are you hanging?
Here's the building. Pretend that. There's my building.
Oh.
I'm like looking down, which I need to demonstrate.
Yes.
So if I was standing on top of this building, let's pretend it's a building, the angle that I would look down at you would be my angle of depression.
That's a pretty. And then the right angle would be right there where the desk is.
Yes. No. I have to look at it from the horizontal, so I have to imagine this horizontal line coming out of my head right now.
So the right angle would be right here.
Yes.
Alright.
Here's what I like to point out. What if you drew down a line like this? You can remember your good old geometry days. You remember those alternate interior, alternate exterior angles? If you don't like to think about it as like the upside down triangle, if this is my angle of depression, isn't this angle down here going to be the same as that angle up there? And so however you can think about it, I always just draw the picture upside down. But if you like to draw the angle down here, just know that those are the same because it's alternate interior angles. Okay? But the big idea is make sure you put your angle in the right spot. And so let's just practice some of these, and you're going to be like, oh, I love this section. Even though it's story problems. Someone said today, I hate story problems, but these are really easy. So hopefully you will think the same.
Before we get to number one, why is the radio tower in the
I just was trying to find a picture, and so I just typed in tower, and this came up, and so I just copy and pasted it. We decided it was a Washington Monument with some hieroglyphics on it. That's what we decided in second hour. But just humor me. It's a tower. It's the amateur radio operator built this tower. It'll work. He can put his antenna on top of that tower, right? 75-foot tower for an antenna. So this is my tower. So could I say this is 75 feet? And that's the big thing on these. If you can label it correctly, then you're just going to set up that trig function the same way that we did on Chapter 4, Part 1 test. Find the angle of elevation. Or if it says the angle with the ground, that's the same as the angle of elevation, to the top of the tower at a point on level ground 50 feet from the base. So this would be 50 feet from the base. I can draw up my angle of elevation coming from the ground. And I don't know my angle of elevation, so I'm going to call that theta. Remember doing these before? So now your job is to tell me which trig function can I use to solve theta. Opposite over adjacent. I've scarred Colton. He's gonna ask every time now before he uses calculator. I know the opposite side, I know the adjacent side, so I can say that tangent of theta equals 75 over 50. And then how am I gonna solve that for theta? And this is where I would say use degrees. In story problems, usually it makes more sense to give your answer in degrees. You're just going to type that on your calculator, and it's going to give you the degrees. Always going to be inverse tangent. Like, look at what they give you to decide which one you should use. 75 over 50. I got about 56.3 degrees. Colton, what happened to your fancy Casio?
I can't find it.
Oh my goodness. Terrible. So let's do one with angles of depression, since that's the part that we haven't done in this chapter. And then we'll do one about as it gets a little bit more complicated. Anyone have a question about that? Anyone need a calculator help on that? The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the surface of the water, to a buoy is 10 degrees. How far is the buoy from the lighthouse? Again, why is this angle depression? Because I'm up at the lighthouse and I'm looking down. I don't know how to draw a buoy. I'm just going to draw this little guy here. Remember that angle of depression has to come out from the horizontal. And so if I'm drawing that in, I think it looks something like that. And they're telling me that the angle of depression is 10 degrees, which means that angle up there is 10 degrees. So I just normally draw in the triangle like this, where there's my right angle. But like I said before, if you want to draw in, like drop this down and draw the triangle at the bottom, you can always flip that down. Like if that's 10 degrees, that angle down here would also be 10 degrees. Whichever way you see it. What am I trying to find? How far is the buoy from the lighthouse? So I want to find this distance down here. Is that the same as this distance up here? Yes, I'm going to call that x. Do I know this distance? Yeah, it's the lighthouse, right? It's just moved over. So the lighthouse is 120 feet. Which trig function should I use? I know this angle. I know the opposite side. I need the adjacent side. So again, I can use tangent, but now this time I know the angle, and I'm trying to solve for the missing side, opposite over adjacent. And that's where you just have to do algebra. It's definitely a calculator problem. You need x out of the bottom. So if you multiply x over, that's going to get x out of the bottom. And then you're just going to divide by tangent of 10 degrees. So you're going to get 120 divided by tangent of 10. And that should tell you how far that buoy is from the lighthouse. I got 680.55. Tell me if you get that. Did you hear that Tyler got perfect on his reading and on the SAT? Isn't that ridiculous? Perfect. 800 on his SAT and reading. I've never known anyone ever in my whole life to get a perfect on part of their SAT.
I think he guessed on a lot of them. I was like, yeah, it's like, really? I was like, so you're all just on a bunch of, I guess I'm just a pretty good guesser. I was like,
Does the SAT still mark you wrong? Like it's better to leave it blank than to randomly guess. Is that still true? which means he didn't leave anything blank. That's impressive. He was in my class when I read the email. And I was like, Tyler! He's like, I've been trying to tell these people this, and they don't believe me because Cora was next to him. And he's like, I just told Cora that, and she didn't believe me. Okay, how can this get more complicated? This is about as complicated as it gets. Just kind of like doing, I think the picture gets complicated again. An observer in a lighthouse, 350 feet above sea level. You might say, well, that's the same picture that was 120 feet. You're right. Observes two ships directly offshore. I couldn't really find ships, so I put rowboats here. The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? What we want to know is the distance from here to here, but we can't find that. But what we can find, just like the last one, can we set up a picture and find the distance from the lighthouse to this boat, from the lighthouse to this boat, and then what would we do? We just subtract them. So it's really just like two problems in one. It just gets a little ugly sometimes when you draw this out. So let's see here. I'm going to draw a horizontal. And I'm going to draw a line down to here. And I'm going to draw a line down to here. If you'd rather draw two separate pictures because you don't want to draw all these lines in one, you can. But it's really just like two separate triangles. I guess I could use different colors here. But like this would be one triangle. And this would be my angle of depression. We talked about in the second hour. I said, how do you know which boat gets which angle? And they said it doesn't matter because it doesn't matter if you don't make the picture right, because when you get your two answers, you'll just subtract and you'll still get the right answer. And that's true. But if you're trying to label the picture right, do you know which one gets the smaller angle? Does this go 4 degrees, or does this one go 4 degrees? The one further away will always be the smaller angle. People said that if you think about it like, look something further away, like it's going to be a smaller angle. But I always just think about it in terms of the picture here. This angle is just going from the horizontal to there, and this angle is going from the horizontal all the way down, which means it has to be bigger than the top one. If I set the 4-degree one up, I'm looking for this entire distance here, right, which I'm going to call x. And then this side is going to be the lighthouse, which is 350. And just like the last problem, do you agree it's just tangent of that? You set the other one up, it would be like this triangle, which I think helps me on mine because I can make it two different colors. Which means this is still 350, but now I'm using the angle 6.5. And I'm looking at a smaller distance. So I called it y, just so that I could have two different letters there. There's one on your homework today, like about a car and a building. Like how far apart is the two cars, or how far did the car travel? It's the same idea as this. But I think I could say the tangent of 6.5 degrees equals 350 over y. And the tangent of 4 degrees equals 350 over x. So how about you work this out, get the two answers, subtract them, and then write it on your little whiteboard and hold it up when you have an answer. Instead of me doing all the work. Just 2 decimals, I guess. Nathan didn't have any papers today, so he started doing all his homework on his whiteboard.
It's not wasting.
It's so I knew it's the new. So that's each one. I want to know the distance in between. So what are you gonna do with those? Should get a big number. It's far away. Not even a mile away. So right? That's what I said. That's far away. And then they point out to me that that wasn't a mile. I'm like, unless it was 5.
Maybe if it was lucky, probably would see me on. I don't know.
What? Where's your whiteboard? Somebody stole it. There's a whiteboard behind me.
Oh, okay. Alright, is that what
Oh,
that?
Jessica has 2 whiteboards.
Oh, pretty cool.
Yeah, that's good.
Yes, that's that's actually pretty
Yes, good, good, good. I think it's pretty good. Hey, look, this is like they hate stickers. So they say that means they're better than stickers. I have to say I agree because stickers are pain. Like, come on, work.
I like the graph.
I know it is nice. I'll make you graph that time. Soon. Okay. Just before we're finishing, this is 4-8 homework. This is it for chapter 4. I'm spending 1 day on this because it's not so bad, which means you have like 22 minutes to work on this. But I also have something else for you. In anticipation of a snow day.
So that's what we had all.
What?
Let's do homework on that.
We've learned, we missed so much school for snow. Normally I can't do this in math because we're learning something new that we're just ready for redoing, so I can't actually.
Yeah. I'm going to laugh.
So everyone get this, and then we'll talk about like what to do with all this stuff.
What if we end up missing a whole nother?
We won't. We only missed so much after Christmas break because it was so cold. Like it was like -40. So they couldn't do anything. Like nothing was melting with snow. But it's not gonna be that cold. So we're gonna. I don't know. I feel like if we do what they say, we're not anything in there. But I think we'll be actually good.
There's supposed to
Oh my gosh.
So here we go. This homework right here is your homework that's assigned today. On Monday, I was planning to give you this chapter review and talk about what's on the test and give you time to work on the chapter review. So if we have a snow day on Monday, this is your homework. If we're here on Monday, this will still be your homework. Because in second hour, they're like, so is this due even, like, is this due on Monday if we come back on Monday? No. The review is your homework for Monday. Now, you probably should get this done or almost done in class today, which means if you want to work on this review this weekend, even if we have school on Monday, that's not going to hurt anything. It's going to let you have some extra time to ask questions and get help on it. But the review is homework for Monday, and I've kind of written it out at the bottom of this. Your review is due on Tuesday, or whatever day we come back, if for some reason we didn't come back on Tuesday, but I think we will be. Because I want to go over questions on Tuesday, which means I want to see that you have the review done. Just like before when we've done this, I'm not going to like count everyone, I'm not going to check everyone. I'm just going to walk around and see that you've made an attempt to do most of the problems and give you some points, and then we'll go over questions. We are going to have a 2-day test for this chapter. Wednesday we'll have the no calculator. Thursday we'll have the calculator. Is the plan for next week if all goes as planned. So I just wanted to give you this today because if we're not here on Monday, I want you to go ahead and start the review. Everybody clear on the rules here? So you have like 20 minutes, so work on this homework so that 1, it can help, and 2, you'll have less to do on your long weekend. What? Oh yeah, sorry, I got a question. 2-minute seconds, but remember you can just type that in your calculator and get decimals. So instead of using that, like just do it as a calculator decimal. Okay? Yeah. Just hit interest. You tell me. The angle of elevation. Right? So they're giving you the angle of elevation. And they're telling you from a point 100 feet from the base. No. No. First of all, what do they ask you to find? How tall is the monument? Yes. Yes, and don't just guess on it. Think about it. 100 feet from the base. It's the base, so that has to be 100 feet. Right? Look, yes, sorry. You have to keep in mind. I'll call you up here and you can look at your quiz, okay?
Can I ask you a question?
About this homework? Yeah.
And it says 100 feet from the base.
Base is positive. So that's how about I just show you what to do that? You could. Cocaine, right? Like if you could use cocaine, you could use tangent, right? Whichever one you want to do. You want to see this color?
So should I find this? Like, should I work that up for you?
You could just type in your calculator, right?
Like, yeah, what should I
But
do?
yes. So it's like homework, so you have to try to focus on it. It's just one answer, right? In the
Looks like